Alright, time for another draftphysics.com, debatephysics.com also. But as stated, debate is so difficult with physicists. People with the more they know, the less accessible they are, frankly. Uh, and you really just can't drag them to these arguments and conversations. And even though we have all this technology and all this ability to do all this kind of stuff, uh, they don't wish to take advantage of any of it. I can't even imagine, 200 years ago, where scientists had to write everything in letters and try to explain what they're talking about, and how much they would just love to be able to send a photograph or a video and argue a subject and talk about it and debate it and all of that stuff. And no, not science now. Yeah, no, science now is just totally uninterested in actually testing any of the physics. It's all just a dogmatic religion. You're either a believer or you're ostracized as an evildoer. One of them. The naysayer, something like that. Anyway, so in our conversation between me and Paul Nord, and so I'll read the conversation later in the video. I'll just get to the basic point. So we're trying to find some way to isolate this problem created by the simple mechanism of a lever, okay? And the argument Steve Mould made was that if you put a lighter object out here and you have a heavier object in here, that this lighter object will consume more energy, okay, to acquire the same momentum, that somehow you have to use more energy, that this can only go 1.4 the velocity, the lighter thing, twice the distance, okay, half the mass, twice the distance, needs 1.4. If I make it a 1 mass and a 4 mass, then it's twice, okay, it needs somehow twice the energy to move it, the commensurate amount on the lever. For the lever to move the same, I would have to apply twice the energy to the 1 mass as I did to the 4 mass. Now, this is in spite of the fact that I think all these physicists would have to agree that I could put a 1 mass 4 units of distance and a 4 mass 1 unit of distance on the stick, and if I hung it from above, it would balance and oscillate perfectly, indicating that whatever these two things are doing, they're equal amounts of energy, because the lever is just flipping the energy from side to side. It's not creating and destroying energy. So with that as a context, we have slightly altered the parameters of the experiment to an idea of a disk spinning. So let's suspend it from a wire, so the weights issue doesn't mean much, and we're just talking about how much energy it takes to rotate it. Alright, so the idea is I could put the 1 masses on the outside, 4 units of distance from the pivot, or I can put a 4 mass 1 unit of distance from the pivot, and all of those should be equal. The argument I'm making is that it takes the same energy to move this one as it takes to move this one as it takes to move this one. So this one's got the 4 mass and a 1 mass, on opposite sides of the fulcrum. This has got 4 masses on both sides, and this has got the 1 mass 4 units of distance from both sides. So it's basically duplicating the ways you could do a lever. And the argument is simply is that, yes, logically, these are all going to spin the same with the same energy input, and I can't create more energy output. That is, this 1 mass can't leave with more or less energy than this 2 mass would leave if I rotated it 90 degrees. So if I rotated any one of these 90 degrees and stopped them, the throwing force for these objects would create the same exact momentum for each, and I can't claim one of them has more energy than the other. So they'll have the same mv, it's just the mv will be in a different form. One will have a big M and a small v, the other will have a big V and a small m. And the question is, how is it possible for them to have different energies when I use the same energy to rotate them? And so that's paradoxical. Okay. So their claim is this one would be the hardest to move. Okay, twice as hard. So you'd have to put in twice as much energy, contact, friction, spinning force, whatever you're using to rotate it. It would take twice as much energy as this configuration. Okay, and half as much from this configuration, because obviously this would have a very imbalance. So they would argue that this somehow has more kinetic energy on one side than it does on the other side, and which is weird, right? Because I would argue certainly it's going to spin on its center perfectly. It's not going to process or do anything stupid, because it's the same energy to move those two objects. They possess the same momentum in their motion, and they create a balance. And even though one of them is heavier than the other, because they're a lever, okay, that part's not going to matter. So it combines both a lever and a disc. Idealization, sort of. Finish that circle. So that's the experiment, and I basically agreed that yes, they all have the same momentum, and he's claiming they have more. One has more kinetic energy, and I'm basically saying, well, prove it, because I don't know how you could possibly make extra kinetic energy as the outcome when the input energy would be the same. And so that's the dilemma. So I guess this would be, it really has to be 1.5, right, of this. So it's 1.5 the amount of energy as this. And this is twice as much energy. That's their claim. So if I got them spinning, this one will do twice the work of this one, and this one will do 1.5 the work. That's their claim. And that this one takes twice the energy to move, which obviously I'm saying, show me. Show me a piece of evidence somewhere that this is twice as hard to spin as this. To get it up to exactly the same rotational speed, I have to use twice as much energy here. No evidence. Yeah, sorry. Yeah, it doesn't happen. I guess I could leave that. Give you something to look at, because I don't think I'll bother showing the text. Because I'd have to pull it all out of the email program and all that nonsense, so I won't bother. So, let's just get to it and such. So it's disappointing. I mean, he's always non-responsive to what I'm actually saying, and now he's just not responding at all. All right, so I introduced the subject to him with my initial video. So I said, just a heads up, I have posted a response video to your response. So he made a 1-minute short. I responded to his 1-minute short. To Steve Mould's video. For 10 years, I've been trying to get physicists to debate, discuss, argue physics concepts. Unfortunately, I have not been able to find anyone interested, even in some cases after offering thousands of dollars. I think many of the conclusions physics proclaims are not well enough evidenced for the degree of confidence. Now, it's hardly a bold statement to say that, gee, you really should have these tug-of-war experiments, you'd have these lever experiments, bounce a ball off a wall experiment. You should really have these experiments. You're going to claim I throw a ball at a wall and the wall has twice as much momentum in it. You really should be able to show me some evidence of that. I would certainly like to hear some of your opinions on some of the foundational subjects, like the kinetic energy theorem, which I would claim is little more than completely unevidenced fable. So obviously this is the subject of Steve's video is the kinetic energy theorem, where he's basically saying, yes, the lighter, the half as light object has to somehow move with only 1.4 the velocity. You can't make it go twice as fast. You have to lose 30% of the energy, the momentum. Anyway, thanks for making the video and best regards and such. And so the response was, thanks for sharing. I haven't watched all of what you have posted. It's a lot. So it's an hour video, but you probably don't have to watch the whole thing. But yeah, again, this is the problem. These people really can't be bothered. You can imagine just how long it would have taken, hundreds of years ago, these guys to write their letters to each other. It would have taken a lot more time than it takes to make a video and have a conversation. So again, I call bullshit. They just couldn't care less about the science or the scientific method. This is the scientific method, actually. Testing and arguing, that's part of the method. The method isn't just proclaiming without evidence. That's not science. That's religion. That's dogma with no accountability. And that's all this is about. Now, frankly, it's amazing that so many people are for unaccountable dogma. They like unaccountable dogma. That's great science from their perspective. All right, Newtonian physics is pretty well established, he says. So we know that they're calling Leibnizian mechanics Newtonian mechanics. So even though Newton did oppose it, Leibniz was his worst enemy, they're putting Leibniz's physics in Newton's mouth, which is pretty disgusting. The predictions it makes are quite useful. Yes, especially the third law. Yeah, equal and opposite reaction, in which kinetic energy always fails to provide an accurate answer by that law. I don't think that you're going to get much engagement probing questions of conservation of momentum and conservation of energy. And that's for the reason is because what? You've assumed something absolutely idiotic, frankly. They're assuming that you always conserve momentum and kinetic energy somehow, when they know, Professor Lewin says it, nature can deal with kinetic energy one way or the other, basically meaning nature can fuck with it. It doesn't matter. It's not a thing. Conserving kinetic energy isn't a thing. And he goes on to say, but nature can't finagle momentum, pointing out that you always have to conserve the momentum. You always have to explain. If you've got less momentum in a system, you've got to explain where it went. Okay, you do raise an interesting question about the competing concepts. So in spite of the fact that it's not an interesting subject, it's an interesting subject. Oh, okay. Anyway, too silly. The competing concepts of momentum and energy, mv squared. These debates are as old as Newton and Leibniz. Yes, that's exactly the point. And they're as unevidenced as they were then, they are still today. So it's just proclaiming the truth. 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. Even though it's not the same momentum, somehow it's the same energy. Says you. With zero evidence. Okay. You may enjoy reading about this visa controversy. So as participants on this channel know, I have talked it to death. Okay, I have gone through every single piece of nuanced data I could possibly find on the subject. Every single commentary written about it I have read. All right. I'm quite aware of all the details. I might suggest you read up. That's just me talking. I might suggest you read up on the subject, as no credible experimental evidence has ever been produced to defend mv squared. What experiment has you so confident? That's what the question I'd like these people to answer. What have they seen in their life that gives them any indication that it's actually true that it takes 25 times the fuel to spin something 5 times as fast? Where in this world do they have some indication that that crap is actually true? Do you think calculations of the kinetic energy, the kinetic energy of thrust landed us on the moon? So it's a simple question. Please answer it, Mr. Physicist. What do you think landed us on the moon? Understanding the mechanics of equal and opposite reaction, that is Newton's laws, or Leibniz's laws? Which one landed us on the moon? Could you just answer the question? Do you think 4 pounds dropped 1 foot creates the same impulse energy as 1 pound dropped 4 feet? Question mark. Kinetic energy fails the lever test, fails the ballistic pendulum, fails crushing cars, fails moving rockets, even fails a simple tug of war. So I should just save that sentence, right? Because this is idiotic to have to drag physicists to this subject when the evidence against kinetic energy is this strong, that it does literally fail all of these tests. Kinetic energy is not conserved in every one of these tests. All right, telling me the dogma is true is just double dogma. Okay, his response. Gary, You might get more engagement with academics if you were a little more gentle. Like what? Okay, I mean, shit, I start off pretty polite. You insulted me first, like I don't know what vis visa is, like I don't know the subject, and I have to go read up on it. So you can be provocative and insulting, but I can't. Oh, okay. And you're a scientist and you don't know what the word hypocrite means? You haven't looked that up in a dictionary sometime? Maybe look up duplicitous hypocrite. Okay. I don't think that most people are going to feel quite so passionate about debating whether MV or 1/2 MVV is the most fundamental quantity. Yeah, because it's real science, and they don't want real science to be true. They want the wavy, phantasmagorical, wooey, wormhole bullshit to be true. Again, all of particle physics, all of their 400 antimatter, all of that bullshit, neutrinos, all the shit is all made out of this stupid formula. That's why they don't want to go anywhere near it. Okay. I don't mean to sound mocking. Yeah, fuck you. But university faculty are a pretty boring bunch. What does that even mean? So he's insulting university faculty. So isn't that interesting that you have less than an impressed feeling about the very academics who are deciding what everybody has to believe? So the Pope and his friends, you're basically saying, aren't great thinkers, yet they're running the show, and you're not protesting at all. Okay, so that's sort of the bullshit here. We have a bunch of talking heads and naked emperors running the physics show. And that doesn't bother any of you science lovers. Okay. I enjoy confusing them too with examples. So he's pointing out that how I'm pointing out contradictions that are quite obvious, and everybody should in some way or other have good answers for these contradictions and paradoxes. You shouldn't just say the solution to the paradox is believe what I just told you. My dogma is the truth, so don't worry about it. It's 1.4. Don't worry about it. Don't think about it. I just say so. That's all you need to know. I say so. Yeah. Bullshit. Confusing them too with examples that seem to defy physical intuition. So I just hate this intuition shit. This isn't an argument about intuition. It's an argument about how you conduct science and whether you're supposed to do experiments to prove what you're saying. And especially when the experiments are really easy to do, when there's no mechanical obstacle to doing the experiment, when it's not like something you can't test, like relativity or something. It's something you can test very directly. Let's say time dilation. Steve's lever example is one of those. All right, I enjoy confusing them too with examples that seem to defy physical intuition. Steve's lever example is one of those. So isn't this ironic? He's conceding it's an interesting subject, but he said before, but we don't want to talk about it. You're not going to get us interested in it. Yeah, it's an interesting subject, but you can't get my interest. I won't watch a more than a 3-minute video. All right, he used the static equations to say something about the dynamic equation. So again, the very idea that there's anything static in the real universe is kind of silly. It's like the random argument. There's no true random. There's no true static. It's just not really a concept. The universe is bubbling, with activity. The experiment with the longer lever will take a longer amount of time. So he says it actually does take more work to move the lighter objects. So again, what's the point? So he's agreeing with the 1.4 in that sentence. So he's agreeing with what Steve did. And then he says Steve missed that. The experiment with the longer lever will take a longer amount of time. So again, what does that even mean? I guess what he's talking about is the dangling sticks. And again, he's saying that somehow the one mass takes more time. It's harder to move. Steve missed that. He should not be surprised that a rocket firing for 1 second will impart more energy than a rocket being fired for 2 seconds. And again, if it fires for 2 seconds, understand the scenario. Then the lever has to move farther, faster. If it's putting more energy in, it has to move the stick faster, not slower. So how could it fire longer if it's done doing its work quicker? It's to the end already. It's already got where it's supposed to be. It got there twice as fast. How can it fire twice as long when it's firing over a shorter amount of time? It has to be a shorter amount of time for the thing to leave at twice the speed. Okay, well anyway, I went over that in a video. In our lab, we hang weights from a pulley and drag a frictionless air cart along by a string. So we know, I've already answered this, so I guess I won't bother reading it because I already answered this whole, well, I'll read it, in a video, that obviously when you suspend a weight from a string and then allow it to fall slowly, you're doing the same thing as if you're lifting weights, and you lift a weight slowly, you're doing a lot more work. Fact. So you're putting more energy into an object when you reduce the free fall speed. By moving masses from the cart to the hanger on the string, we change the net force on the system while keeping the total masses the same. So the net force, he's saying, is changed. So obviously the slower you move it, the slower it falls in the gravity, the more energy you put into the object. So heavy things will collect more energy, light things will collect less, because light things will move very fast and heavy things will move very slow. The velocity of the system is predicted precisely by the change in potential energy of the system. So again, they're saying it's mgh. So he says here 0.05 times m times v equals mgh. So 1/2 mv squared equals mgh, which is the same thing as saying energy equals mgh, when obviously the h, the height, it makes a huge difference. If I lift it quick, I lift it slowly, I'm going to do more work. Same thing with dropping it. If I drop it slowly, I'm going to do more work. If I let it fall quickly, I do less work. Here, m is the mass of the hanger, and m is the total of the mass of the cart and the hanger. Actually, this experiment is a very close analogy to Steve's confusion. So he keeps saying Steve's confused. Steve's arguing for 1.4, and so is Paul. Okay. The total kinetic energy needs to be conserved. So he's saying we have to conserve kinetic energy. You don't have to conserve the momentum. So you can destroy 30% of the momentum, completely inverse to what Professor Lewin says. That momentum has to be conserved, and kinetic energy, well, who cares? Okay, his magical masses rockets confused his intuition. So again, he's saying that somehow the rocket does more work when it moves the lighter object. You can't calculate the work done on the rocket as it has no mass, so it doesn't matter. It's applying a force. So whether you throw the rock or you throw the force that threw the rock, doesn't matter. So if I hit a wall with my hand, same thing as me hitting the wall with the ball that was in my hand. You're not going to change anything. Also, the animation showing the rocket moving at a constant velocity did not help either. Well, lots of things didn't help. The different size levers didn't help. Lots of things in the animation weren't perfect. But the very idea that you can have the rocket firing longer as the lever moves faster is idiotic. Okay. Can't happen. All right. And then he says the second example was rolling things down a ramp. So when we roll down an incline and predict how far it will launch from the end, the velocity at the end is predicted precisely by modeling the potential energy change and the energy that goes into the rotational energy of the ball. So again, ignoring the fact that the only way this experiment is all interesting is when you change the mass of the ball. And obviously the heavier ball will be gaining more energy because it's got more energy in its flywheel, so to speak, in its rotation. So when it hits something, it's going to have more energy. It'll roll at the same speed, but when it hits something, it's going to show you that it collected more energy. So the longer the thing dawdles on the ramp, the more energy it's collecting. We can hit the mark on the floor within 1%. So I'm just arguing, yes, but you're not hitting the mark in the sense that it's 9.8 meters per 1 second. Okay, it's a time-dependent force, so you're way off the mark in thinking it has something just to do with height, when it has something to do with how long are you being affected by the gravitational pressure which is causing a weight. How long do you have your weight? How long is your weight being applied? And that's the real energy driver. All right, that one comes up a little short, which is probably due to the frictional losses to the ball chattering, so he's making excuses for why it doesn't come out that well. Anyway, but it might be slipping, and it might be air bubbles inside the delirium balls, which were delirium balls, wow, would give them slightly lower moment of inertia. So again, more nonsense concepts. There's no moment of inertia. Okay, mass is mass and velocity is velocity, and that's it. There's just mass and velocity, and everything's made out of units of mass. There are electrons and protons, and they're all equally hard to push. So it's just as hard to push one electron as another electron, and it's just as hard to push one proton as any other proton. And you're just saying how many electrons are you pushing, how many protons are you pushing, and that's all that'll ever decide what energy is in the universe. You're welcome to throw out classical mechanics. So I'm obviously not throwing out classical mechanics. I'm revering it. I'm saying Newton was brilliant and right. Okay, and Leibniz was a religious kook and wrong. And create your own. I'm not creating my own. I'm defending a well-established 2,000-year-old Archimedes principle in this case. I'm defending Archimedes in this case. But be aware that you'll need to explain the experiments that I just described and many more. Well, those are easy to describe. You'll have to explain why physics fell for denting clay with round objects. Or do you actually think that's a credible experiment, that you can measure something's energy by denting it with an irregular shaped object? Did you fall for that too? Mockingly, I ask. You're welcome to throw out... I already read that, right? Yeah. Now that you've got me thinking about it, so after he did this crap of, oh, fuck you, you can't argue physics, we already decided what everything is and it's real solid, then he starts thinking about it. I'm really surprised that Steve was able to confuse minute physics. So there's the joke, okay? Minute physics did defend the idea that, the half mass will go twice the velocity. He showed pulleys, and that's what pulleys do. So you can move the half velocity at twice the speed, the half mass with twice the speed using the same force that moves a one mass at 1 unit of speed. I do agree that this Atwood's machine, so the Atwood's machine is some simple thing. I can't remember what it was exactly. But anyway. Is a better model for seeing the levers problem more clearly. Well, anyway, I can't remember exactly what it was, but it's really simple. If you watch the 7 minutes of my last video, so I gave him a link, I explained the real dynamics of the MGH pulley experiment. So again, this is the very same experiment, where, physicist Michael did it. Lots of people do this experiment. And again, they're assuming, their assumption in the experiment is it doesn't matter how fast you move something up and down in gravity. It's always the same work. So if I do it really quick, same work as if I do it really, really slowly and keep holding the weight and keep pushing it up and keep holding it. Same work. So even though the weight will be clearly hugely different into how much weight you supported in total, same work, which is a nonsense, absolute nonsense. Let's see, I'll take care of the angular momentum ramp experiment in the next video. So he's making an I explained the real dynamics of the MGH pulley experiment. I'll take care of the angular momentum ramp experiment in the next video. Well, I don't think you will. Okay. Not beyond my critique, which will be obvious and stated, that the longer something is in gravity, the more it's going to apply its weight, pressure, on a surface. I can slide across thin ice and not break it because I'll be applying less weight to it, because I'll be having gravity affect me for a less amount of time. Fact. Just for clarity, you agree with Steve Mould, so no, I don't agree with him, that levers don't conserve momentum. Of course I don't agree with him. So I don't know how in all this he didn't figure out that I'm defending momentum. And he actually asked the question that levers don't conserve momentum, and I agree with that, when of course I don't agree with that. Okay. you don't think a one mass going one velocity can produce enough leverage. Oh, that was me talking. My mistake. Sorry. So I was asking him, just for clarity, I'm just trying to find out whether he believes this 1.4 thing or not. And so I didn't get a direct answer, in my opinion. You don't think a one mass going one velocity can produce through leverage a half mass going two. So the one mass on one side of the lever, I drop the one mass on this side of the lever at one distance, and it'll make the half mass move twice the velocity on the other side. That's the simple argument. And do you believe Steve Mould's 1.4, or do you believe momentum is conserved and it leaves with 2? No. So he says no to the question. So the last question I asked is, do you think a one mass going one velocity can produce through leverage a half mass going two velocity? So he's saying no, he doesn't believe it can. So he believes the 1.4 thing. I believe that Steve is mistaken. So again, Steve is arguing for the 1.4 thing. So I don't know what you're, so there's no way to figure out what side he's on. Is mistaken about interpreting his calculation. So, there's just no way to win here. Momentum and energy will both be conserved. So that was a trigger sentence, of course. I mean, it's just so... I'm sorry, it's almost pathetic that these people haven't figured out that I can't conserve both when I transfer energy from a light thing to a heavy thing, or from a heavy thing to a light thing. It's impossible to conserve both. He's failed to model a real physical device pushing the other end of the lever. So yes, he's claiming that it's an uneven amount of energy being provided, and frankly, bullshit. And he confused a bunch of people in the process. That's exciting. So he's excited but not very interested. Something like that. All right, so I respond. Momentum and energy will both be conserved. I put that clearly in quotes. And I said, I can find no way to interpret this as a reasonable statement, especially in the case of the lever. In the provided example, there are only two possible outcomes. The half mass leaves with 1.4 the velocity and the momentum isn't conserved, or it leaves with twice the velocity and the kinetic energy isn't conserved. There's no option that says both are conserved. That option isn't available. All right. Can you show an example where both are conserved? Simple enough question. Okay. Before opening with, how can you possibly think that momentum and energy are conserved? You should say both conserved. So he didn't quote exactly what I said. He quoted something I didn't say. Perhaps you can show me your calculations. I mean, just amazing. The calculation is MV in equals MV out. There, we're done. Did you have some diagrams or equations that you've used to work through this problem? So again, it's just ironic and hilarious. What's to work out? Momentum is conserved. I just have to add up masses and velocities and I'm done. All right. If you really do want to undermine the whole body of knowledge in the physical sciences, I want to undermine the propaganda and the lies. The idea that kinetic energy works when kinetic energy didn't land us on the moon. Please take a moment to do the calculations from the perspective of your classical mechanics textbook. You just want to say, oh, fuck you. If we can design an experiment that shows a contradiction, we already showed the contradiction, for fuck's sake. The lever already shows this is impossible. You can't have it both ways. You can't conserve both. So you have to explain how one works and one fails dismally. And then you have to explain how it's possible that your energy theorem fails dismally. I promise that I'll meet you in Oslo for your Nobel Prize. So again, just more... let's just throw in some little tacky insults. The subject really isn't worthy. You're not worthy, because we're pretentious douche. And that's it. Okay, so I said, well, again, you have been totally unresponsive to anything I wrote. I put simply, I'm merely asking to see the evidence that has you so convinced, so confident. You use the word classical as if it isn't part of the dispute. 350 years ago, an argument started between Leibniz and Newton, mv versus mv squared. You're claiming that classical mechanics is Leibnizian mechanics. I'm arguing that Leibniz didn't win the argument with evidence, and that I have no good reason to agree with you that Newton was wrong. For 350 years, your kind has been saying 4 pounds dropped 1 foot is the same energy as 1 pound dropped 4 feet. I repeatedly ask for some physical experimental evidence, and you can provide nothing. So just done 350 years, and they haven't bothered to test the axiom that is the foundation, the cornerstone of this idiotic claim. Newton's basic equation was force equals momentum. Twice the force, twice the velocity. 3 times the force, 3 times the velocity. Meaning they're the same thing. Velocity and force are the same thing. If the word energy had existed, I'm quite certain he would have said force equals energy. If the word work had existed, I am sure he would have stated that all motion is created by having a force do work on it. I clearly pointed out that I think MGT defines the energy from gravity. This argument isn't about equations, it's about what is conserved. I am plainly challenging to show experimental evidence demonstrating kinetic energy being conserved in any circumstance where energy is being transferred between two unlike masses. You have provided nothing. Okay, so I'll respond to what you've said. That's all wrong. Please show me your calculations. So that's it. That's all he responded with. Okay, nothing. What do you want calculated? I'm claiming that all interactions mv in equals mv out. I'm claiming that gravity is a time-dependent force, and if you want to know how much force something has collected in free fall, the formula is mgt equals E. Energy. You are just being evasive. One more time. Does a half mass in Steve's Mould's example leave with twice the velocity or 1.4 the velocity, assuming the same initial force? If you agree it is twice the velocity, you must concede that 1/3 of the kinetic energy has been lost. So I made a mistake in that last sentence, so I corrected it in the next email. I said, sorry, I should have said gained twice the kinetic energy instead of 1/3 of the kinetic energy being lost. So obviously what you're losing is the kinetic energy in one case and the momentum in the other. If you think it leaves with 1.4, then you have lost 1/3 the momentum. So I just corrected the last sentence. I think that Steve's problem is a good starting point. I can't get you started. Okay, can you set up the equation? So again, he just keeps doing this, right? So we've been through Archimedes in the videos, all these different arguments. You won't watch any of that. And the equation is dirt simple. The distance is essentially equates perfectly to velocity. So 4 times the distance, 4 times the velocity. So it's just basically the mass times the distance, which is, in this case, the velocity. The distance and the velocity will be the same. In the case of free fall and gravity, the distance and the velocity aren't the same. 4 times the distance is only twice the velocity, not 4 times the velocity. So in this case, it matches. Can you set up the equations in terms of your favorite scheme? We'll need some diagrams, vectors, masses, lengths, etc. Then we'll have something to discuss. So he won't watch a video, but he wants diagrams, vectors, masses, and lengths. But he won't watch a video. So I posted a video. What else can you do? So I did post a video diagramming the whole thing again. Alright, so your rotating unbalanced rod is a good concept to consider when talking about this problem. So now we're to the disk again. And I think that it's the core of what Steve missed when he described it. So again, he's saying Steve missed something, but he's defending Steve's idea of 1.4. So that's the part just that doesn't make any sense. I mean, it's nonsensical, plainly. The two masses are spinning around a common axis. Yeah, we all got that part. Let's not worry about how they got there. Well, let's worry about how they got to their momentum, how they acquired their speed. the larger mass is twice the mass of the smaller mass, and the smaller one has twice the distance from the axis. So we're just redefining the lever again. If the circle swept out by a larger one has a circumference of 1 meter, the circle swept out by the smaller one has 2 meters. So we already do that. The distance is commensurate to the amount of distance you'll travel, which means it will be commensurate to your velocity. If the spin once per second, the distance traveled for the large one will be 1 meter in a second. The distance for the other one would be twice 2 meters, of course. The small one will have a velocity of 2 meters. Okay, I can calculate the momentum and the energy for each of those objects before you stop the stick. Yes, and the whole point is their momentum is the same and their kinetic energy isn't. And therefore, somehow, you have twice as much energy on one side of the balance as you have on the other side of the balance. So we're right back to Steve Mould's argument that somehow the 4 mass has twice as much energy. I mean, the 1 mass, 4 units of distance, has twice as much energy than the 4 mass at 1. And yet, how could it possibly oscillate perfectly? All right, after you stop the stick, they will keep moving with those same velocities, yes, with the same momentum. And they will move in a straight line. Yes, and one of them will have twice the kinetic energy. Well, in this case, 30%. Each will therefore continue to have the same energy and the same momentum that they had before they were released. So the same energy and momentum before they were released. The point is which one required more work to move. You're saying the one disk takes more energy to move. You put more energy in somehow, but it only created the same momentum. So you put 30% more energy in, and you only have the same momentum out. Do you agree up to this point? So obviously I said no. Paul, I would agree with the calculation that the half mass is moving twice the velocity, the 1 mass is moving 1 velocity. The 2 objects have the same momentum. They do not have the same kinetic energy. Your obligation is to explain how the balanced wheel can have more kinetic energy on one side than the other. Right. Nothing about this problem requires energy of each of the 2 to be equal and opposite. So he's saying that a balance doesn't have to be balanced, that you can have twice the kinetic energy on one side than you have on the other side, and it's perfectly reasonable. The momentum of each is opposite, and the center of mass of the system will always be in the same place. So again, he's saying the lighter wheel going twice as fast does twice the work, or some kind of argument like that. So he writes out object A, object B, and basically just points out that, yes, exactly what we're stating, that they have the same momentum, and he's just claiming they have this kinetic energy imbalance magically was created. So somehow the wheel did take more work to spin, because how else can you make more kinetic energy on one side? If there's more kinetic energy on one side, I had to put more energy in. Since momentum is a vector quantity, it will have a direction. So this is more baby talk. Since they are always moving in opposite directions, the net momentum is 0. Obviously, just baby talk. A spinning saw blade does not have a momentum of 0. None of these numbers will change after the stick is removed. Do you agree? The total energy of the system is always 6 joules. No, it isn't. Okay, the total momentum is always 0. Well, saying the momentum is 0 is just, again, the recoil of the gun is not 0. So nonsense. So I did post another video, and he says, I don't want to spend another 30 minutes watching a video. Okay, so you really don't want to discuss physics, because frankly physics takes that kind of time. Did you agree with everything I said in the last email or no? And I say, personally, I don't think much of arguing physics in 1-minute videos and text threads, but whatever. I agree that the momentum is the same and the momentum is conserved. Clearly, I don't believe kinetic energy is a real thing, so I don't accept your energy equals stuff. Okay, the problem doesn't seem to be as complicated as you are making it. If you defend the 1.4 thing, you are claiming momentum can be created and destroyed. Okay, great. We now agree velocity is not of neither object changes when they're released. Yeah, well, obviously they don't change when they're released. Why would I never made any argument claiming that? Nobody did. Newton didn't. Nobody did. You're happy to compute mv and say that does not change. Yes, I will go on to compute mv squared and claim it also doesn't change. The change is from how much energy you had to put in. To get your kinetic energy numbers, you had to put extra energy in. So again, you have to explain how it actually does take 25 times the force to spin something 5 times as fast. You have to explain how that's true. All right, you are free to believe that this concept of energy is a fiction, but can you also agree that the math I've shown you so far checks out? What math? There's no math. You're just making up some kind of fable and telling me there's this fable energy that doesn't have to balance in a lever. So I can make a balance, a gravity balance, and I can put 2 things on it, and one side of the balance can have 100 horsepower, and the other side of the balance can have 50 horsepower. I'm saying that's nonsensical rubbish. I asked that you provide specific physics problems to discuss. You suggested the situation of a spinning lever rotating about its center of mass and then releasing 2 masses. Yes, that's what I suggested. Now we've put some numbers and equations into the problem. You didn't put the most important number, that is, how much energy do you give this spinning disk? You have to explain how it got to be spinning, because that's going to be either 1.4 the energy or twice the energy. I think that we've agreed that the situation conserves momentum at all times. I'm claiming that it conserves energy. Well, how could it possibly? Because you haven't defined what you sped it up with. Did you speed it up? Did you give it motion with a speeding bullet, or did you give it motion with a recoiling gun? Because obviously those 2 things, if they're not going to give the momentum to the object, they have the same momentum. So if they're not going to convey their momentum and they're going to convey their kinetic energy, well, the bullet's going to give it 1,000 times more spinning power. Do you think that the energy... You don't think that energy is a thing, but do you agree with any of the math I've discussed so far? There was just no math, all right? So this is just, again, this is just so silly. Do I agree that MV is at the core of your equation and that you're just putting a square on it for what I can claim is no good reason whatsoever? So I said, yes, 2 times 1 is the same as 1 times 2. So what's the punchline? How does 1.4 pop out? So that was my last question. I think it's a fair question. The analogy is to Steve Mould. Steve Mould says the lighter mass can't be moved twice the velocity with the same amount of energy. It can only pop out with 1.4. It has to lose 30% of the momentum. That's his assertion. Levers destroy momentum. That's the assertion. So anyway, so tedious. I mean, it's just, like I said, it's just demonstrates these people just don't care about science in any rational definition of science. They're just religious fanatics. All right, so back. So let's just go over it just real quick one more time. So the idea is that this is 4 units of distance. Okay, 1 mass, 4 units of distance, and this is a 4 mass, 1 unit of distance. All right, and that their claim is this requires twice the work, twice the energy. You have to put in twice the energy to spin this wheel as you do to spin this wheel. That's their assertion. Okay, and that when you stop this from spinning and allow these objects to fly off, that yes, obviously it'll have twice the energy, but you put twice the energy in, so somehow that will equal some kind of kinetic energy theory thingy. Okay, so bottom line, so if all these disks are spun at the same speed, okay, and they were to do work on some object, the argument I'm making is they all have exactly the same momentum, and they will only be able to transfer their momentum to pins or other balls or anything they're going to be exchanging their force with. They only have the force of their momentum, and this one doesn't have twice the energy or capacity to do work. They will all do the same work because they all have the same momentum, and that's all they can ever transfer. That's all you can ever transfer is momentum. That's Newton's second law. Transfers are momentum transfers. There's nothing else you can transfer. You can only transfer your momentum. All right. And of course, the third law says it all over the place in talking about explosions and cannons and guns and other things where you have to distribute the energy evenly in a spherical manner with things that are pressure. It has to be. Can't do 4 that way and 1 that way. It's not the way nature works. All right. Simple enough and such. So till the next time and such. I think that's all I can do. So disappointing. But that's life on Earth. It's disappointing. People are very, very disappointing. And that they have no integrity. yeah. No courage, no integrity, no honor, no dignity, none of that. They're just schemers and shysters for personal causes.